our last sections, we were talking about exponential functions. So we started thinking about how functions behave when we change the exponents, right? 2 to the 1, 2 to the 2, 2 to the 3, and so on. And we saw, right, we saw how quickly, if we go back here, back to the olden days.
Oh, this is on the
Here.
packet.
Yeah. So we saw back here, right, when we were graphing 2 to the x, that, when we change the exponents by 1, -1 to 0 to 1 to 2, our values jumped very quickly from half to 1 to 2 to 4, and so on. All right? So now that we know how exponential functions behave, we're going to go here. All right, and we're going to do a little bit of an exercise before we get started with anything else. Okay, so here I have 2 to the 1, right? And how much is that? 2. Okay, now I'm going to why can't I write? Okay, I'm going to increase the exponent by 1. Now I have 2 squared. What do I get? 4. And then I'm going to change the exponent by 1 again. 2 cubed. What do I get? 8. So what happened? When I changed the exponents, my values jumped from 2 to 4. And then from 4 to 8, I skipped all of these numbers here, right? I skipped 5, 6, 7, all of those. I never hit those. So now, what if I was hoping that I could raise 2 to some exponent and get 6, right? What happened there? What exponent of 2 will give me a result of 6? I totally skipped that, right? When I went from 1 to 2 to 3. So if I were to ask you, what would you guess that value to be? 2.5? Okay, so if anybody has their calculator handy, can you plug in 2 to the 2.4? Just one person is good enough. 2 to the 2.4.
Not you, Jacob.
How much is it?
5. If I round 5.3.
Okay, 5.3. So what other guesses do you guys have?
2.5.
2.5?
I'm guessing 2.7. Oh.
What do you think?
5.
Okay, so
6.
Still not good enough.
2.6.
Let's go 2.7.
2.7.
That's what I think.
6.5.
Okay, so now we went over, right?
2.65.
Okay, so 2.65. Let's do 2.65.
2.6.
Okay?
Yeah. 6.3.
Okay, 6.3. Okay, so now we could just go, okay, so 6.5 didn't work, so maybe it's 2.61. Maybe it's 2.6125.
Yeah.
So we could sit here all day, go back and forth, back and forth, back and forth in order to zero in exactly on that value, on the exponent that would give us a 6. Okay, so now put your calculators down for a minute. Just put them face down on your desks. Stop touching your calculators. Face down. Okay. So the question we're trying to ask now is, what is the exponent going to be of 2 so that 2 to the power of that will give me 6? Okay? So that's the question. First, we need to understand the question. 2 to the power of what gives us 6? That's the question. Now, to answer that question, what we need actually is a logarithm. Okay? So what is a logarithm? A logarithm is something that answers the question of what exponent of a given base will result in a specific value. So that's a logarithm. So throughout this chapter, I will always ask you, what is a logarithm and what are you going to say? A logarithm is just an exponent. It's the exponent that you're looking for. So let's try that. What is a logarithm? An exponent. That's it. The trick to understanding logarithms and to be successful with logarithms is to associate those two words in your mind. Logarithm is an exponent. That's it. A logarithm is just an exponent. When you solve for a logarithm, what you find is an exponent of some base. Okay? That's it. Okay. So let's talk about logarithms and powers for a minute. Take a look at this one. This whole thing, 3 squared to the equals 9. Okay, so 3 squared, we call it a power. A power has a base, in this case it's 3, and it's got an exponent, right? We all know this. This is the base, this is the exponent. Now, this is one way of writing it. 3 squared is equal to 9. Another way of writing the exact same thing, another language, is this. So you say log, okay, so this is how we read these. Log base 3 of 9 equals 2. So now, log base 3. So take a look here. If this is the base of the power, then it goes in the base of the log. Okay? The exponent, remember, is always the answer to the logarithm. Answer to the logarithm. And this value, okay, goes in here. So there are lots of things out there. When you work with an older, like a friend, a sibling, a parent, a tutor, or whatever, and they will tell you something about a snail method. I hate that method. Okay?
Sorry, I was just...
So I know, it's super cool. So,
Can I turn it off though?
yeah, we're not gonna use that word snail, okay? We're gonna, huh?
You don't like it? I never understood it.
Because it makes no sense with the math, okay? That's something, okay, whatever I could use to explain or whatever I could use to get a 6-year-old to get an answer to a math question, to me, is useless because it's not showing you any math. Like if I use some mnemonic device or whatever to get a 6-year-old to get an answer for this, have they understood logs? No, they haven't. So to me, it's useless. But, okay, we're going to do it this way. So now, here's what we're going to do. Let's practice a little bit. 2 to the 5 equals what?
32.
32. Okay, so 2 to the 5 equals 32. Now here, where is the base of this here?
It's the 2.
This is the base.
Log 2 equals 5.
Right. So log base 2 equals the exponent always. Okay? So if I were walking down the street and I saw this on a billboard, I'd be like, oh yeah, 2 to the 5 is 32, because that's how I interpret that in my head, right? Because look, base, exponent, base, exponent, and that's the value. Okay?
Does this get any harder or is it just like this?
A little bit. Once you understand, it really can't get very hard. Okay,
Yeah, I did it too.
good. So 4 squared equals
16.
16.
Brennan.
So now how are we going to write this?
Log base 16 equals 2.
Do you have to say base?
No,
Yeah, log base 4 of 16 equals 2. So now, let's think about it. What is this asking? It's asking me 4 to the power of what?
2.
Gives me 16, and that's 2. Okay? The answer to the logarithm is always the exponent. All right? So, look at this one.
3 cubed equals 27.
Right. So, this is the base, 3. Every base needs an exponent. What's the exponent? It's the answer to the log, equals 27. Okay? All right. So we can easily go back and forth between logarithmic and exponential form, right? So here we call this exponential form, and we call this logarithmic form. All right? All right. So let's talk about properties of logarithms. Since a logarithm is an exponent, right, we always have to think about like those special exponents, okay? So let's remember a couple of things. So what's any number raised to the power of 1?
The number.
The number, right. What's any number raised to the power of 0? 1. We already know that from last chapter. So let's explore that for a little bit, okay? So take a look here. 2 to the power of 0 is what? 1. So if I write it in logarithmic form, that's what it looks like. All right. What's 3 to the power of 0? 1. So if I write it in logarithmic form, what does it look like? Log
3 of 1.
log base 3 of 1 equals 0. Okay, so 4 to the 0 is 1.
So log 4 of 1 equals 0.
Okay. B to the 0 is what? 1. Anything to the power of 0. Table to the power of 0 is 1. So this is log base B to the power of 1 equals, okay. What do you notice? What's an inference you can make?
It's
What's a,
the answer on it. So log answer is always 0. And
okay.
exponent is 0.
So when you have, okay, so does it matter what the base is? Whether it's 3 or 2 or 4 or B, it doesn't matter.
Anything with a 1 right there.
Okay, that's it. No matter what the base is, log of 1 is always 0. Okay? Doesn't matter what the base is, log of 1 is always 0. Because if I just have this, what am I asking for? I'm asking 3 to the power of what will give you 1, and that's 0. Okay? So that's one inference that we just made. So log any base B of 1 is always 0. Okay? Now, so that's an exponent of 0. Let's talk about exponent of 1. 2 to the 1? 2. Let's write that in logarithmic form.
Log base 2 equals 1.
Right. Okay, 3 to the 1? 3. Let's write that in logarithmic form.
Log base 3, 1, 3 equals 1.
Right. Okay, so let's go ahead and do the other ones. 4 and B. Okay, so what did we get for this last one here?
Log base B equals 1.
Okay, so
Whenever the base and the other thing are the same.
then you get a 1. Okay, so if the base and this value are the same, then you get a 1. Does that make sense to us? What is it that these things are asking? So what is it that this thing with the 4 is asking?
How many powers does it take to get to 4?
Well, right. It's asking 4 to the power of what gives you 4, and clearly that's 1. So doesn't matter what the base is. If this value is the same, then what's the exponent to get there? It's always 1. Okay? Yeah.
Since we can't use our calculators for this chapter,
Uh-huh.
for this section,
Uh-huh.
if you give us, are you going to give us like high exponents?
No.
We have to,
Okay, so now take a look at these. Take a look at these these properties. Look at this one. We just came up with this all by ourselves. Okay? B to the power of what gives you 1? What should the exponent be so you could get a 1? It's 0. What should the exponent be so you get a B again? 1. Okay? So these we just came up with on our own. Okay, so take a look at this one. B to the power of what will give you B to the x? X. So what should the exponent be so that that equals B to the x? Well, x. Okay? So if you have something that looks like that, log B to the power of x, that's just x. Okay. Here, same situation. So take a look at this here. B to the power of log B of x is just x. Okay? So just remember that log B is x, right? And then B log B will also go away and you have x. Okay?
Okay.
Let's do some practice with these exponents right now. Okay. Let's talk about roots. You learn about roots in algebra and then in algebra 2 or intermediate algebra, but we always forget. So when we're talking about logarithms, often we're going to run into roots. So remember that a root can be written as a base with a rational exponent. So if I have square root of 2 here, or square root of any number, there is an index here of a 2, okay? Now, I can rewrite this as the base 2 to the power of 1/2. Okay? So, roots always give you a fractional exponent of 1 over something.
So then that would be 1/3.
Correct. So then this next one will be 2, and since this is cube root, it'll be 1/3. 20. Okay. So this one is 25 to the power of 1/3. Okay. Right. So that's, we could go further for this. We could go further here. Look. What's 25? 5 squared, right? I could write it as 5 squared to the 1/3. Okay. So it's not a matter of what we like or don't like. It's a matter of what the problem calls for. Okay. Again, it's a matter of what the problem calls for. I'm never going to ask you, put this in rational form. We're going to have this inside a logarithm, and then you have to do whatever the logarithm wants you to do. Okay? All right. So that's one thing, is roots. So this is like crash course of algebra 2 right now. Now, fractions. Okay? Remember here, we've already worked with fractions, you just don't know it. Where was it? Okay. Okay, so remember here, when you have 2 to the negative exponent of 1, what does that give you? 1/2.
Yeah.
Okay, so now, if I were to give you 1/2, would we be able to go back and say, oh, that's the same as 2 to the negative 1?
Yeah.
Yeah, so that's what we're going to do now. Okay? Because sometimes we need to be able to write it that way. So, 2, because this is 2 to the 1 underneath, if I wanted to move it up to the numerator, I could say that's 2 to the negative 1.
Oh my God, that makes
Okay.
That makes so much sense.
So, anytime, so if I have like 5x over y, okay, anytime I could move something on top to the bottom, or from the bottom I could move it up and just change the sign of the exponent. So, I could do this. I could do 5 here. I could move the x down if I wanted to and say x to the minus 1. I could move the y up if I wanted to, and I could say y to the negative 1. Okay?
Wait, are x and 5 not attached to each other?
No. It's 5 times x, so they're separate. Okay. So here. Oh, sorry. Okay. Now, here's what we're going to do. We have to evaluate some logarithms. Evaluate means get an answer, a numerical answer. Okay, so here's my question to you. What is a logarithm always?
The exponent.
An exponent. All right, so if you're evaluating a logarithm, you need an exponent. Okay, so here it is. If I were walking down the street and I saw this on a billboard, I'd be like, oh, somebody's looking for an exponent of 2.
It's 4.
There you go. So you're asking yourself. So you ask yourself,
What is 2
yeah, 2 to the, exactly. And what is it? 4. Not much work to show here. That's why this will go on the non-calculator section.
Yeah, but when you get to a big number.
I know, but I won't give you such a big number. But you know what? Yeah, you'll be okay. So what about this one? What's the exponent of 5?
5.
You need the exponent.
5 to the what equals?
Uh-huh.
2.
What is 2?
The what is 2?
5 squared.
5 squared is 25. Okay.
So if you write 5 squared, that's
Yeah, no, you don't write 5 squared. You just write 2. Remember, what's a logarithm, Liel?
exponent.
An exponent, so you just write the exponent.
Oh, so then for 3,
Okay.
is it 1/3?
No, this one, yeah, so this one we have to rewrite it. The root 3, we're going to write it as 3 to the half. Okay. Right. We don't leave root 3 as is. So we write it as 3 to the half. And now, if you have log 3,
3 to the what equals
Exactly. So then it's just 1/2. Okay? Because what I'm looking for is what exponent should this have so it looks like this? 3 to the what is 3 to the half? Well, it's a half. In the, when we're doing these in, in bulk, right? We just go, oh, log BB goes away, so it's just a half.
So it's not
Okay?
super complicated. I was
Yeah.
gonna think it was like 3 to the negative.
Yeah. So what about this one? 8 to the what gives you 512?
3.
He says 3. Okay, go ahead and check. If you're doing this at home, you can check. And if you're doing it on the test, I will give you numbers that you know. So is it 8 to the 3? What's 8 to the power of 3?
It's that's 64.
It is 3.
No.
Yeah, Brennan.
8 to the power of 3. 8 to the power of 2 is 64.
How did you know that?
So that's 3. Okay, so how would you know that? 8 squared.
Is 64. 64 times 8 is 412.
8 squared is 64. And now, if I need to multiply this by 8 again. If I multiply 8 and 4, do I end with something with a 2 here? It's 32, so chances are that's what it's going to be. Remember, exponents increase the value very, very quickly. So you could either, do trial and error on your calculator if it's homework, or you could ask Liel, or you could just guess.
It's the middle of the test. Hey,
Yeah.
What's
So on the test, you will have numbers that you know. Okay, so 22 log 22 will go away, all right?
it'll just be 50.
So it's just 15.5. That's the property here. I didn't go to great lengths to explain it. I'm just asking you to trust me.
So
I know
the
it goes
answer is
again.
always the small
Right, if it's
exponent.
b log b. If it's b, okay. This next one is super, super important. Okay, so this one, let me go through it. I know some of you can already do this. So you have log base 3.
3 negative.
Okay, hang on. I have 1 over 3. All right? It's very, very important that here, what's the base here? 3. Okay, it's important that here you have something that's the same as the base. So 1 over 3, I could rewrite it as 3 to the minus 1. Okay?
And then it would
And now that is just minus 1. Okay, because log 3 goes away.
Oh. Interesting.
Yeah. So that's the trick. When you have a fraction, you can convert it to a negative exponent. Okay. Okay.
Yeah.
Yeah. Okay. So this one, here's what we're going to do. Look at this. I had a base of 3, a whole number, and then I had a fraction here, right? And how did we go from a whole number to fraction? It was a negative exponent, correct? So now, here's how I do this. I'm going to go again from a whole number to 1 over something, to a reciprocal. Listen. I'm going to go from a whole number to a reciprocal. All right? That means I'm going to have a negative in my exponent. Now, forget about the fraction whole number bit. What's the exponent of 5 that gives you 125, Leo? 3. So that's negative 3. Okay? Let's do another one. Okay, so here's how I do it. Here's how I do it. I'm going to go from an integer, a whole number, to a fraction. That means I need a negative. Okay? Then I forget about all that, and I just want the exponent of 5 to get 125, and that's that. Okay, now let's do some more. Let's do another one. Log base 2 of 1 over 16. Here's how I do it. 2 to the what is 16?
4.
4. But because I'm going from whole number to reciprocal, negative 4. It's not a matter of liking, it's a matter of doing. Okay. So, log base 2, cube root of 2.
2 and 1/3, right?
Right. We're gonna rewrite this as 2 1/3. So now it's, hey, write these down.
1/3.
1/3. Okay? Okay? Okay. Now